Hello, 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 and welcome to another episode of Mr. Boskin Does Some Math. Today we're doing Illustrative Math, Grade 8, Unit 2, Lesson number 9. To start out, these two triangles are similar. What are A and B? Note the two figures are not drawn to scale. So, if they're similar, all of the angles have to be congruent to each other. And if they're similar, all of the side lengths have to have a consistent scale factor between one triangle and the other. So for these two triangles here, A is on the small triangle. So to go from the large triangle to the small triangle, we have to look at corresponding sides. This side with a side length of 10 and the side with a side length of 4 are corresponding sides. What do we do to 10 to get 4? Well, 10 times 4/10 is 4. So to find A, we have to do 15 times 4/10 to get A. Fifteen times 4/10 would be 15 over 1. 15 times 4 is 60 over 10. 60 over 10 is 6. So A is 6 units. Now to find B, we have to see what do we do to 4 to get 10. Well, we multiply it by 2.5. So what do we do to 9? To get B? No, 9 times 2 is 18. 9 times a half is 4.5. B is 22.5. Okay, what is next? Here is triangle ABC. Triangle XYZ is similar to ABC with a scale factor of 1/4. Draw what it would look like. What XYZ might look like. So if it has a scale factor of 1/4, to be similar, it's going to have... That's not my best drawing ever. I'm trying that again. Sure. Scale factor of 1/4. So the bottom, which was 4, 4 times 1/4 is 1. 5 times 1/4 is 5/4. 7 times 1/4 is 7/4. That could also be 1 1/4, and that could be 1 3/4. How do the measures of angles compare? Because the two triangles are similar, we know they have to have congruent angles. What are the side lengths of triangle XYZ? Ooh, Somebody rushed and already did that. For triangle XYZ, that's our new triangle, calculate long side divided by medium side and compare to triangle ABC. So on this one, we had long side divided by medium side would be 7/5. XYZ is going to be 7/4 divided by the medium side, which is 5/4. Ooh. Somebody should say, hey, Mr. Boskin, you should do this where it shows up on the screen. There. Now you can see it. ABC is 7/5. XYZ is 7/4 divided by 5/4. Dividing fractions means multiplying by the reciprocal. So it's 7/4 times 4/5. Those 4s are going to cancel and we're left with 7/5. How do the calculation of long side divided by medium side compare for the two triangles? 7/5 and 7/5. They are equal. So the ratio of side lengths will be equal. Two triangles shown here are similar. Find the value of D over C. Well, as we just did on the last problem, if the two triangles are similar, the ratio of side lengths are the same. So the value of D over C has to be the same as 7.5 over 9. So 7.5 over 9. That's an ugly fraction. We don't leave a decimal in a fraction. 7.5, let's just double it and that'll get rid of the fraction. That would be 15 over 9, which simplifies because both of those are divisible by 3. 15 divided by 3 is 5. 9 divided by 3 is 3. 5/3. The value of D divided by C should be 5/3. Okay, the diagram shows two nested triangles that share a vertex. We've got a big triangle and we've got a small triangle. Find a center and scale factor for a dilation that would move the larger triangle to the smaller triangle. So we're trying to go from this big guy to this little guy. Where's the center of dilation going to be? Well, that's got to be the point that does not move. What point on here does not move? Well, this vertex right here. Maybe if I do it in red, that will show up better. There we go. That's more visible now. So that's the vertex that didn't move. That point didn't move. So that's our center. And now we need a scale factor. We're going from big to little. So our scale factor is going to be between 0 and 1 to make it smaller. How much smaller did we go? Well, 1, 2, 3, 4, 5. The big triangles, 5 units by 5 units. 5 units wide, 5 units tall. And the new one is 1 unit wide and 1 unit tall. So we turned 5 into 1. So our scale factor is 1/5. Scale factor is 1/5 because we made it 1/5 the size. We turned 5 units into 1 unit. So center of dilation is here, scale factor of 1/5. I think that's our last problem for today. This has been another episode of Mr. Boskin Does Some Math. Thanks for watching. See you next time.